Okay, in this last part of this lesson, we're going to talk about how is the magnetic effect of current applied in circuit breakers. Okay, so we now know that a current always produces a magnetic field around it. When you coil a wire instead of a straight wire, you coil it, suddenly you get the fields to be produced in such a way that resembles a magnet. You basically get an electromagnet. And so by shaping the wire into a solenoid, you can get an electromagnet, right? And so that's the application of circuit breakers, which is actually something we've talked about already. So I'm gonna go quite quickly through this, okay? So circuit breakers are an application of electromagnetism. A safety device that switches off the electrical supply when there's excessive current flow. So when there's a lot of current flow, you switch off the device. How does this work? The core component is an electromagnet. Okay, this is a diagram that is not the same one as the one that I've shown previously. So I just want to show you that it can look like different things, but the concept is always the same. Okay, the concept is always okay, I'll talk about that later. Okay, but basically overview, the concept is always that there's an electromagnet, and when the current gets very large in the electromagnet, we already learned that how do you increase the strength of the magnetic field? By increasing the current, right? So if the current is very large, the magnet will become very strong, and then it will pull something away, which will open the circuit. Okay, so that's always the principle. In this case, now currently the switch is on. Okay, the switch is on. So the switch is on, is pushed down. This is the contact point. So the circuit is closed here. Okay, so the circuit, you can see it flows. See, it goes around the magnet and it comes back down, and then it goes and then it flows up. Okay. So the current is below the limit. Magnetic field produced by the solenoid. There is a magnetic field, but it is weak. It is not strong enough to pull this catch away. So the soft iron latch is not attracted to the solenoid. This is a soft iron latch. And the safety bar, this is a safety bar with springs, stays in position, and the interrupt point remains closed. The interrupt point is basically just the circuit. Okay, they're just like the switch. See, current flows normally. But what happens when there's a surge? There's a short circuit or overloading, there's a surge in current. What will happen? So now, the surge in current, a very large current flows through the electromagnet. So number 5, you can see here number 5, magnetic field produced by solenoid is very, very strong. And so it will attract the soft iron latch. Okay, the soft iron latch is attracted to it. So previously in this video, the soft iron latch is keeping this spring closed. This safety bar is spring closed. But when it gets attracted, it moves down, so it releases and it flies out. Okay. So you see here, it's attracted to it, and so this thing flies out. And now the switch is in off position. And then you see the interrupt point opens. Okay, I think it's the next thing. So you see spring is released. Safety bar is pushed outwards such that the switch is in off position. Interrupt point here is open. And so the circuit now is an open circuit. Electricity no longer flows through. Circuit is broken. Okay, so this is how we use it in circuit breakers. And the principle behind it is that we use an electromagnet. The larger the current, the stronger the magnetic field strength, and so the stronger the magnet. Okay, so this is a very useful tool that we use for circuit breakers. Okay, this is in your syllabus, so circuit breaker question, can be tested in your O-levels. That's why we went through it specifically. Okay, so with that, your homework is worksheet 18B. Okay, worksheet 18B, question 1, section A, and section B, question 1 to 3. Okay, please go at it, and you'll get your next lesson dropping soon.